For 1 second, let's assume that gravity, the curvature of space-time, is not caused by a local mass, but instead it is the non-local interactions relative to that local mass which curves space-time. So in this scenario, the curvature of space-time is not a product of local mass, but mass is a product of the curvature of space-time. What would this tell us about wave-particle duality and the Heisenberg uncertainty principle? Particles, as we know it, are excitations of probabilistic waves. Can we agree that in our everyday life, raindrops do not fly upwards? They fall down based off of Earth's gravity, pulling it down. As you can see, this is a normal droplet falling down, and when it hits the water, it all spreads out and diverges away from the droplet. This is normal, and there's nothing crazy about this. What if we were to reverse this so that raindrops do actually fly upwards, and it's not raindrops, instead it's quantum particles? So now here is a reversed example, and as you can see, the water seems to converge, and so eventually the converging water will create an excitation for a droplet to start flying upwards. If that droplet is analogous to a quantum particle, then the water is analogous to the spacetime around that particle. In our everyday world, I would be the source of the droplet, and the effect would be the wave. But in the quantum world, the source is the wave, and the sink is me, the observer. When the particle flies up and into the cup, I interact with it, and I am the effect, and I am not the cause. And so, when we are interacting with quantum particles, our measurement is the effect of non-local space-time, the information of that particle converging to create the excitation of that particle when it reaches our detector. Imagine this as the space-time of a particle. The moment we make a measurement, we are interacting with it, but in reverse. We are non-locally causing the space-time around that particle to converge, to create the excitation to eventually reach us. Somehow, we are triggering this converging wave non-locally when we are measuring particles, and so the droplet flies up. This is still probabilistic, but it's not local probability. Local probability is the effect of non-local probabilities and their interactions. What if we are holograms? Our local interaction, so me locally picking this up, is actually my non-local version picking up the non-local version of this. And what emerges is what we locally see. Okay, so what about Heisenberg's uncertainty principle? The more we know about the position of a particle, the less we know about its momentum, and vice versa. And if this is a local particle, and we understand its momentum, its velocity or whatnot, then we won't know its position. Will then mean that the position is non-local, it's spread out. And so of course we can't figure out where this particle is. So then if we know the position of a particle, then we won't know the angular momentum as much. And so, what if that angular momentum is then transferred over non-locally? And so it's the non-local version of that local particle that carries over this momentum aspect so that the local position is understandable. Is anything fucking real? Well, yes, but we live in two versions of reality. We have a local version of us and a non-local version. Okay, we're starting to get kind of woo-woo, so I'm going to end the video here. I hope you enjoyed the video. Hopefully this made some type of sense, and if not, then it's okay, because I am a self-proclaimed crackpot, so it's not like I have any fucking understanding of this shit. I'm just yip-yapping. But I hope you enjoyed the video anyway.